Welcome to the lecture video for Algebra 2, Chapter 1, Section 2. This section is on evaluating and simplifying algebraic expressions. We tend to use those two phrases interchangeably, but they actually are very different, and we need to make sure that we are following the directions carefully as to whether they say to evaluate or to simplify, and we have to make sure that we are doing what we're supposed to be doing. Now, evaluate means that you're going to get a number answer. You're going to get something out of your work. Simplify just simply means to make smaller or more simple. So we have to make sure that we're very careful as to what we're doing when, and whether the direction said to evaluate, which is when we get an answer out, or whether we are simply going to just simplify, which means make things smaller. Okay. First thing we're going to do is talk about evaluating powers or exponents. So the first thing is, what is an exponent? Well, we have something like this. This is considered a statement with an exponent, but these types of statements consist of two pieces: the base here and the exponent itself, or the power. Those phrases can be used interchangeably. Why this is important: the power tells us how many times we're going to combine something, and the base tells us what we are combining. So what I mean is, exponents are just repeated multiplication. So we look at our base. Our base here is 3, so that means that that is what we're going to be multiplying together. The exponent tells us how many times we're going to multiply together. So our exponent is 2. So that means that we're going to have two pieces, and our base is 3, which means that each piece is going to be a 3. So that means 3 times 3 is 9, which means that 3 squared is 9. And this is the process that we're going to go through. I understand some of you are going to be thinking to yourselves, why not just use the calculator? You have to be able to do it both ways, so we need to make sure that we know how to do it. So let's take a look at something like this, 2 to the 4th. I want you to pause the video, and I want you to write this out, and then come back and see what's going on, and then we'll take another short break while you evaluate it. Alright, so welcome back. And again, our base here is 2, our power is 4, which means that we're going to have 4 repeats, and each repeat is going to be a 2. So 2 times 2 times 2 times 2. Alright, so this is what you should have. If so, congratulations. Now take another short break and multiply it out. Okay, so you should get 16 as your answer. So I hope you're good with exponents and powers, because we are going to move on to the next statement. Okay, up next is going to be how to simplify and evaluate statements. We're going to have to use our order of operations. And most of you know your order of operations is just PEMDAS, but you have to know what they mean and why it's important. So for the P, that stands for the parentheses. These are first. We deal with parentheses above everything else. After parentheses is the E, which is exponents, and then M, which is multiplication, D, division, A, addition, S, subtraction. Why the order of operations is so important is it's simply what it says. It's the order in which we complete our operations. The operations are addition, subtraction, multiplication, and division. But we have to make sure that we do them in the right order so we can get the right answer. And that's all PEMDAS is about, but you have to make sure that you're using it. Just because you know it doesn't mean anything if you're not applying it while you're working on your work. So, the order of operations in action. The first thing we're going to deal with is the P. And again, what's P stand for? Correct, parentheses. So, do we have any parentheses? Yes or no? Yes, we have a set right here. So that means that we're going to look inside the parentheses first. So, nothing changes outside. We are going to just change whatever's inside the parentheses. So now we're looking just inside the parentheses. So 5 take away 3 is 2. So now we're looking at this. Okay, again, we're done with parentheses. Next on our list is the E, which stands for, very good, exponents. Do we have any exponents? Yes or no? Yes, we have a power right here. So that means that we're going to deal with that. So we get 1 plus 7 squared is 49. And then times our 2. Now, technically speaking, this should not have parentheses. You can include them, but you don't have to. They don't change anything. All right, so after exponents is m, which stands for, very good, multiplication. So, do we have any multiplication? Yes, we do. It's right here, that little dot. Remember, there's 3 or 4 different ways of writing multiplication. So we're going to multiply those two together. And 49 times 2 is 98. So we've got multiplication. After multiplication, we have D, which stands for, correct, division. Do we have anything being divided in here? No. So we don't need it. Up next is A, which stands for addition. Do we have addition? Correct. So what's 1 plus 98? It's 99. And then subtraction is left. We don't have any subtraction, so we're done. And this is what you should get out. But if you don't do the order exactly right, there's a very high chance of you getting the wrong answer out of this, which is why the order of operations is so important. So again, it's not just that you know them, it's that you can use them. Okay, evaluate. Now over here, this was using the order of operations, and this would have been an evaluate as well. How do I know that? Well, what did we get? We got an answer that is a number. So whenever you get out just a number, that means that it's an evaluate. So take a look over here. Evaluate negative 4x squared minus 6x plus 11 when x equals negative 3. Again, they're saying evaluate. That means that we have to get out just a number. No letters, nothing else. Just a number. So the first thing we're going to do is substitute. They say evaluate this statement when x equals negative 3. So they're telling you the value of x, so we can write this with just numbers, which is what we need to be able to do. So, start off by substituting. And all that means is that you replace the letter x with whatever it's equal to right here. Now you have to make sure that you use parentheses. Whenever you substitute anything, I don't care what it's in, if ever you're substituting, you have to use parentheses. Okay? So that way when you square or multiply, your answers have the appropriate sign. That is the #1 killer for answers, is that you do all the math right, but you missed a sign and you'll get everything wrong. So you have to make sure that you're using parentheses here and here whenever you're substituting. Okay, so first things first, parentheses. Do we have parentheses? Yes, we do. Is there anything inside these parentheses that we can do to make things smaller? No. So we're done with the parentheses. What's next? Exponents, correct. Do we have any exponents? Yes, we do. And this is where I'm talking you have to watch your signs. The negative is inside. So that means that we're going to take negative 3 and repeat it 2 times. So that means that negative 3 squared is actually going to equal negative 3 times negative 3, which is in fact positive 9. So if you got negative 9 here, the reason is because you just typed it into your calculator without those parentheses. So you have to put them in. Is what? Multiplication, that's right. Do we have multiplication? Yes, we do. It's not written out explicitly, but you notice right here and right here, when you have a number written outside of a parenthesis, it is in fact multiplication. So negative 4 times 9 is going to give us a negative 36. And negative 6 times negative 3 is going to be positive 18. Okay, remember, a negative times a negative, 2 negatives, always makes things positive when it's multiplication or division. And here, 1 negative makes our answer negative. Okay? So, do we have any division? No. Do we have any addition? Yes. We have addition right here. So what is 18 plus 11? That's right, 29. And do we have any subtraction? Yes, we do. Right here. So if you have Negative 36. So like you owe your best friend $36 and you pay him $29. Do you still owe the money? Yeah, we do, because the bigger number here is the negative. So we know that our answer is going to still be negative. And then you subtract the two values. So 36 take away 29 is 7. And that is your final answer. So when it comes to evaluating expressions, you have to make sure that you're substituting first, and then it's just using your PEMDAS. But again, just because you know that your order of operations are the letters PEMDAS doesn't mean much if you can't use them. So please be careful. Okay, here we're going to start by combining like terms. So first of all, what does it mean to make terms alike? Or first of all, what is a term? Mathematically speaking, a term is anything divided by an addition sign or a subtraction sign. So if you notice up here, we have three terms. We have our first term of 3x squared, our second term of plus 5x, and our third term of minus 7. Now, in order to combine terms, they have to be alike. And in order to be alike, that means they have to have the same variable to the same power. So each term is going to have two pieces. They are made up of a coefficient, which simply put is the number that leads, and it's made up of a variable. Now, a variable is just a letter that can change. We don't know what it is. That's why it's a variable. It's unknown. Now, in order for terms to be alike, they have to have matching variables and matching powers. So if we take a look, 3x squared is going to be our first term, so we have to identify which part is the coefficient and which part is the variable. And our variable here is x squared. So that means that in order to combine anything with 3x squared, it must have an x squared in it. So let's take a look at our second term. What is our second term? That's right, plus 5x. So now, which piece is the coefficient? 5. And what piece is the variable? Just an x. Is that the same as the one before it? Nope. So we're going to change colors here. And there's the variable. So can we combine 3x squared with 5x? You're right. We cannot combine these two pieces because they are not like terms. How do I know that? The first term has a power of x squared, and the second term has a power of x. In order for them to combine, it has to be the same variable, which we have, but it also has to have the same power, which here it's a 2, and here it's a 1. So we're stuck. So now, the third term is negative 7. What's its variable? Right, it doesn't have one. So that makes it its own piece. Whenever you have a term with no variable, it's called a constant. As in, it never changes because there's nothing impacting it. It just is negative 7. Okay, so you got to remember the vocabulary here. In order to be a like term, we have to have same variable to the same power. Okay, we have terms which are divided by plus or minus signs, so this one happens to have 3. And each term is broken up into two pieces, the variable and the coefficient, which is the number in the lead. So you have to make sure that you're using the appropriate language. So let's take a look, combining like terms. First things first. Our first statement here is 8x plus 3x. So again, where do you draw division lines to divide up your terms? Between plus or minus signs. So how many terms do we have here? We're going to have 2. The first one is plus 8x, and the second one is plus 3x. Now we want to simplify, which means combine and make smaller. So in order to do that, we have to identify our terms and what the variables are. So what's the variable of the first term? X. That's right. What's the variable of the second term? X. So are these two terms alike? They are, which means that we can actually combine them. So if you have 8 x's, and you're going to add 3 more x's, how many total x's do you have? You have 11 x's, and that is your final answer. Okay, coming back over and looking at this second problem right here. Same basic approach. You're going to divide up your piece into its terms. So plus or minus signs are where you draw divisions. This one has 3 terms. And now we need to try to figure out whether our terms are alike or not. So, what's the variable for your first term? Close, not just p, but p squared. Okay, what's the variable for the second term? That's right, it's just p. And what's the variable for your third term? P squared. Now, do we have a p squared already up here? Yes, we do, so we're going to use the same color, so that way we can show it as being alike, because it's the same color. Now, there's one really, really tricky thing they're doing up here. Take a look at your second term. Is there a coefficient? No, one is not written, but that doesn't mean that there isn't one there. Okay, whenever they give you just a variable, there's a coefficient of 1 in front of it that isn't written, but is there. Okay, so now we have our terms identified, and are there any of them that are alike? Yeah, you said earlier that we have a 5p squared here and a 2p squared here. So we're just going to perform the mathematics. So if we have 5p squared and we take away 2p squared, how many p squareds will we have left? That's right, we'll have 3. So we use this term and we use this term, so we're done with them. And what's left? Correct, just the 1p all by itself. And that is your final answer. So when it comes to combining like terms, you have to determine which pieces are the terms, figure out what the variables are, and then group them accordingly. So you're going to group by variable. So the variables that match go together. Always, always, always. Okay, and that's it for this section. Here's your homework. Take a look, page 13 through 14. Some of these problems you might have a hard time with, but that's what this video is for. So if you have questions, make sure you bring them into class.